Right, a smart. So now let's go here and see. Now see here. So the dot class files, the dot class file I have shown you, right? After compilation, you will get the dot class file is loaded into JVM. So see, this is the JVM. Every machine has its own JVM. JVM is not same for a Mac, Windows, and Linux. Linux operating system, it is different. Windows operating system, it is different. Mac operating system, it is different. Okay, but the bytecode file is common to all the environments. So JVM will take the bytecode only, right? So you can create a one Java file and you can run on multiple machines. That is called a platform independent. So why it is a platform independent? If anybody asks you, so you need to tell Java code can be run on multiple platforms. So like Windows, Linux, Sun Solaris, Mac. Java code is compiled by the compiler and converted into bytecode. This bytecode is platform independent code. So because it can be run on multiple platforms. So this will provide the concept, write once a code and you can run anywhere, any platform you can run. So based on this concept, you can see it is a platform independent programming language, architecture neutral, and portable language. So all these features are based on this bytecode only. So why Java is a secured programming language? So Java is a secured and virus-free system applications we can develop. So why it is secure? So because if you observe this, so Java application runs, see, OS, this outer layer is a OS, operating system. Operating system inside you have a JVM. JVM inside your code will execute. That's why so many layers, right? So it provides the protection. But here, operating C++ application runs on the OS level itself. That's why that is not that much secured. And also in the Java, you don't have a pointers concept. So that is the reason. And also it runs very deep inside the JVM machine. And also JVM has a lot of components. So JVM has a lot of concepts, class loader, bytecode verifier, security manager. All these components are there in the Java virtual machine. I'll explain the Java virtual machine, don't worry. And you can understand the architecture of a Java virtual machine. And also Java is a robust programming language. Robust programming language means it's a strong programming language. So what is a strong programming language? Why you call it is a strong is it has a strong memory management. It has a strong memory management. So there is a lack of pointers concept that avoids security problems. So there is no pointers concept. So you have so you can avoid the security issues won't arise. Automatic garbage collection. I mentioned, right, in last topic. Automatic garbage collection means any unused objects are available in the application or in the system. This garbage collector will collect them and clean them. So that means it is freeing up memory for you. So that's the main reason here why it is more stronger. And also there are other topics very efficient topics in any programming language. You have exception handling. So runtime, when you're running time, error occurs, you don't know where it is occurring, why it is occurring. You can catch them easily with the exception handling concepts. And what is the reason for error? What is the reason for a failure? You can easily find out with this exception handling concept. There is a type checking mechanism. That means what type of data you are assigning to variables and identifiers. You can easily be checked by Java. So all these points makes Java very, very strong. And architectural and neutral means I told you, it doesn't depend on the whether your system is a 32-bit or 64-bit. It doesn't matter. Anywhere your code will execute because of bytecode. And also portable language, I told you, you can run Java code on any environment or any platform, any hardware or software environments you can run. It is high performance language because of the interpreted programming language. Java bytecode is little bit faster. And a distributed programming language, you can develop the distributed applications like RM and EZB concepts are so used for creating the distributed applications. Those are so anywhere from anywhere you can access if you have internet. That's the distributed applications. Across the globe, you can access the applications. Multi-threaded. So multi-threaded thread is nothing but a separate program, so which executes concurrently. So we can write a Java programs, so that has that has to perform many tasks at once by defining multiple threads. The main advantage of multi-threading is it doesn't occupy memory for each thread. It shares the common memory area. Okay, well, one object if you create, that will be occupied by some memory. Same memory you can use it by multiple threads. For example, same video is accessed by so Rajeshwari and some other persons. For all of them, same memory will be reused, but different threads will be used. That's the multi-threading means. Anywhere this multimedia or web applications follow this multi-threading concept. So dynamic programming language. So automatic loading of the classes. For example, Java has its own code. That code you can reuse. So while reusing, so required classes will be loaded automatically to you. You don't need to worry about that. So that is the dynamic programming language means. So these are all the features of Java. What are all the features of Java? Java is a simple, object-oriented, secured, platform independent, distributed, high performance, portable, architecture neutral, multi-threaded, a dynamic programming language. That's all about Java features. So we need to understand now the difference between JDK, JRE, and JVM. So let's understand first what is JVM. So JVM means Java Virtual Machine. It's an abstract machine. Any laptop or desktop or any server, if you install Java, JVM is available there. So it is available there. So it is an abstract computing machine that enables a computer to run a Java program. So JVM has a specific task it will perform. So it executes the bytecode as I mentioned already. So bytecode you will provide to the JVM. JVM will execute that bytecode line by line and it produces the output to you. So what are the tasks it will perform? 4 tasks. First, load the code. First, once a bytecode is generated, that will be loaded into JVM. Then verifies the code. So it verifies the code, whether the code is proper or not. So executes the code and provides a runtime environment. So that's the task, 4 tasks the JVM will be performed. This diagram is not appearing, but okay. So how does the JVM will work? So let me give you this JVM because JVM architecture. JVM. Okay. So here is one. You can go. I think this is the better one. This is the better one. Okay. So this is the better one. See, as I mentioned, right? First, the bytecode will be loaded into JVM by class loader. Class loader is the one of the subsystem in JVM. This is all JVM architecture, guys. The first component is a class loader. Then memory areas. This green color, right? Memory areas. Then you have a execution area. As I mentioned, right? Interpreter, JIT compiler, native interface, native library. So I will upload this in our so here, but this is the first class loader. What it will do? A class loader. So class loader is a subsystem in the JVM. The main purpose of class loader is the bytecode will be loaded into JVM by this class loader component. What is the purpose of class loader? Class loader will load the dot class files into JVM. That's the class loader responsibility. So where is this? This is the one, right? This is the bytecode. The bytecode is loaded into JVM by whom? The class loader component. Then it will go and store in the memory areas. What are the memory areas? Heap area, stack area, method area, Java stack, PC register, native method stack. So what are the memory areas? Heap area, method area, or static area, and Java stack area, PC register, native method stack. These are the memory areas, 5 memory areas. So once it loaded, it will go and store in respective memories. So which memory, what data will store, I'll explain you in detail later. First, remember this diagram. Then from these memories, the code will be taken care by this interpreter and executes the code. And this just-in-time compiler will improve the execution speed. And this native interface and native libraries, so which is, so whenever already existing code will be loaded into this native method stack. So from here, the interpreter will take all the code and execute the code and produces the output to you. That is the same thing I explained here. So again, class loaders are 3 types are there. Bootstrap class loader, extension class loader, application class loader. So class loaders, how many types? Bootstrap class loader, extension class loader, application class loader. So Bootstrap class loader is responsible for loading the classes from Bootstrap class path. So nothing but rt.jar. So this is the highest priority will be given to the class loader. First, this will be loaded. Then extension class loader responsible for loading classes that are inside the ext folder in your Java installation. So JRE lib folder, this extension class loader will be there. Application class loader. So this is responsible for loading application level class path. Whatever the application classes which are available, that will be loaded by this application class loader. So that's the how, and then class loaders will verify the code, prepare the code, and resolve that any issues are there in that. So that's the linking will happen in these memory areas. So that's the memory partition. Then runtime. So basically in this heap area, method area, and Java stack, PC register, native method stack. So in this, what data will store, I will explain later, because now if I explain, you won't understand much here. So I'll explain this later. Execution engine, as I mentioned, interpreter is the main one, which executes the code, and just-in-time compiler is the, which improves the performance of execution. And there is a garbage collector also, one more. So the garbage collector is responsible for reclaiming the memory. So if one object you created, but you are not using that, then this garbage collector will go and clean up that. And that's it, reclaims the memory back. So that is what this garbage collector will be done. So that is all about the JVM architecture. Okay, I'll upload this in here. So please go through that. And then JRE, as I mentioned, Java runtime environment. If you want to execute your code, you need a Java runtime environment in your system. So Java runtime environment has a JVM, set of library files, and other files will be there. So once you have a JRE, then only code can be executed in your system. Otherwise, you cannot execute the code. Then JDK, Java Development Kit. So mainly if you want to develop the applications, like Java applications and applets, if you want to develop, so you should have a JDK in your machine. So JDK inside, basically JDK is nothing but a combination of JRE plus development tools. Development tools means compiler, Java compiler, Java. So there are other tools like archiver and document generator. These are all available in the development tools. These two combination is called JDK. So that's why from Java 9 and above, you are not going to see JRE separately. But Java 8, you can see JRE separately, JDK separately. But Java 9 onwards, you will see only JDK. So only one folder you can see. You cannot see JRE separately, JDK separately. Let me show you that. I have JDK 11. So that's why if you install JDK 11 in the program files, so Java, see only one folder will be there. So you don't have JRE. Why? JDK is mix of JRE plus development tools, both combined. That's why only JDK is enough. From JDK 9 onwards, you will see in your system. No JRE separately. It is there inside JDK, JRE is there. Separately, you don't need to install. But before Java 9, Java 8 to Java 7, these are all JRE separate and JDK separate. So when you install Java, you will get two folders. But the Java 11 and 9 onwards, you will get only one folder, JDK folder. So that's what all this JRE, JDK, and JVM main difference. Okay. Any questions? That's all about theory part. Please go through these questions and try to solve this. So whatever till this point, I think. till this point. So you solve it, and these things are still I haven't explained. Maybe later you can solve these things. Okay. So till this you can solve your questions. All these questions you can answer. So tomorrow that's 12 questions you need to answer. One by one you can answer, and selfie video you can send me that. Okay. Yeah.